Hi future doctors, welcome to the next class. In this class, we'll discuss about self-induction. Coefficient of self-inductance, it is denoted with capital L. So, in a coil of inductance L, if current is passing, if I current is passing, so whenever current is passing around the current carrying coil, what will be developed means magnetic field will be developed. Because of that magnetic field, so magnetic flux linked with this coil is going to be changing depending on this I. So that magnetic flux linked with this coil phi is always directly proportional to current passing through that coil. If current increases, flux also increases. If it is having only one turn, so we are going to write phi. If it is having n number of turns, then we will write total flux is going to be n phi. So n phi is directly proportional to I. So n phi, if you write, is equal to, we will write L. So this L only we are calling it as coefficient of self inductance. So L is equal to n phi by I. So what are the units for this? Generally flux units we will call Webers, current units amperes. So Weber per ampere. So this one only we will write Henry, capital H they are going to call. So L is equal to n phi by I. But already we came to know according to Faraday's law. So induced EMF E is equal to minus L di by dt. We are going to get, how we are going to get means E is equal to, according to Faraday's law, d phi by dt for one turn. For n turns, minus d by dt of n phi minus d by dt of, what is n phi we got here? Li. So if you wrote L constant outside, minus L di by dt. This is the induced EMF formula. So very important formula, you can do very easily problems also. So this L is self-inductance. So how this self-inductance will be acting means acting means it is going to oppose according to Lenz's law. Therefore, this one also we will call it as inertia. Mass is a measure of inertia. It will be acting as inertia of electricity we are going to call. Now within this coil, which energy is storing means magnetic energy is going to be stored. How much energy is stored within this coil? So what is the energy stored and what is the magnetic energy and energy density also we will see. And what is the self-inductance of this solenoid or coil we are going to discuss. So all energies we will derive from work done equation. So from this power we came to know in electricity, voltage into current. Why? Because we came to know induced EMF and we will get from power work done dW by dt. Derivation is not required, just we are giving. Now E is equal to, we came to know, minus L di by dt. So this negative symbol only opposition which is going to oppose, therefore we will remove later di by dt into, so this dt will be cancelled. So dw is equal to Li di. So if you do integration on both sides, dw w, so L I square by 2. So this is only of Li square is the magnetic energy stored in the coil or inductor we will call. This one we will call either inductor or coil also they will say. Magnetic energy. Next, magnetic energy density. So like capacitor, if you have seen, what is the energy stored in a capacitor means that is electrical energy. In EM waves lesson, this one will be coming of CV square. This is of Li square. So what is the energy density we got here? U by V of epsilon naught E square. Here what you will get means energy density per unit volume of, in place of epsilon naught, we compared magnetism and electricity, 1 by mu naught came. In place of electric field intensity, we will get magnetic field intensity. Therefore, U by V is equal to B square by 2 mu naught. This is the energy density. V is nothing but volume of this coil. This coil volume is different. So this coil volume is different. So volume is nothing but area into. Therefore, this is the energy stored in energy density we will call. Energy stored, magnetic energy stored per unit volume. So energy density is different, energy is different. So which energy this one means? Energy stored in the form of magnetic field. Therefore, magnetic energy. This is electric field. Therefore, electrical energy in capacitors. So blindly you can follow. In capacitor, electrical energy will be stored. In coil or inductor, magnetic energy will be stored. Now, what is the self-inductance of this coil? How we are going to calculate? We will see. Now, see here. If I current is passing through this coil, so magnetic flux phi is equal to what is our formula? BA cos theta. If it is having n number of turns, n phi, n BA cos theta. Next, theta is the angle between magnetic field and area of the coil. Isn't it? So NB, direction of area, like this. What is the magnetic field at center of this solenoid? We came to know already. So both are in same direction means cos 0. Magnetic field at, so north pole, south pole we gave. Did you remember? Solenoid. So anti-clockwise, north pole, clockwise, south pole. So again I am not discussing all this. Both are in same direction, cos 0, N. So what is the magnetic field intensity at center of solenoid means mu naught Ni. I is the current. Area is nothing but pi r square. You can write area of this coil. If each turn radius is nothing but small r. Now what is small n here? Small n is nothing but number of turns per unit length. So within this length, how many number of turns are there? Because if length is going to be changed, number of turns also will be changed, isn't it? So length of this solenoid is different, length of this solenoid is different. So on this less number of turns we are going to, therefore in place of the small n we can write capital N. So mu naught n by L into I pi r square. This is nothing but n phi. This n phi you can compare with Li, because n phi is going to be equal to Li. So just if you are comparing, so I if you remove in place of L, what you got remaining? So mu naught n square, mu naught n square pi r square by L. This one only they will write mu naught n square A by L also. This is in terms of number of turns. So L is directly proportional to n square, inversely proportional to L, isn't it? So in terms of small n also we can write. How we can take in terms of small n means, here in place of capital N, what we can write? Capital N is going to be small n into L. So in place of this capital N, if you write small n, so mu naught n square L square A by L. So one L will be cancelled. Then what we are going to get? L is equal to mu naught small n square AL. So you have to remember, while pronouncing we will pronounce same n square. But whenever capital N is coming, L is in denominator. Whenever small n is coming, L is in numerator. Remaining all things are same. Mu naught capital N square A by L. Mu naught small n square L A. So this is the self-inductance of solenoid. So self-inductance formulas, how many are there? You can see in how many ways you can solve. In one of the they asked a problem on this equation. They gave L, they gave I. What is the energy stored? So in this induced EMF they will ask. L they will give, change in current they will give, in how much time it is going to be changing. What is the induced EMF? Isn't it? Self-inductance will be acting as a inertia in mechanics. Next, see, a coil which is having only one turn, radius R, is going to get I current. Then what is the self-inductance of this coil, they will ask. So always we'll calculate this N phi, because N phi is equal to L I. Now what is the flux passing through this coil? Phi is equal to, what is our formula? BA cos theta. So what is the magnetic field intensity produced because of this current carrying coil of radius r? Means already we discussed this. At its center, what is the magnetic field it is going to develop? Means mu naught I by 2 r. Now what is direction? Whenever curve, means I told you to take 4 fingers like this. So then magnetic field direction is outside. Area of this coil outside. Therefore, cos 0. Angle between B and A is 0. Because area is outside, normal we have to draw like this. So magnetic field is also outside. You can use right hand thumb rule also. Current is passing like this. Here it is into, here it is outside. So phi is equal to B A cos 0. What is B here? Mu naught I by 2R. What is area of this coil? Pi R square. This is phi. Only one turn, therefore n value is going to be 1. If it is having n turns, then we will get n. That is secondary. Next, 1 R will be cancelled. Mu naught I pi R by 2. This is going to be phi. Compare this one with this. So phi is equal to Li, because only one turn is there. So if I got cancelled, Li. Cancel means comparison. L equal, what you are getting? Mu naught pi r by 2. This is the self-inductance of single coil which is having radius r, I current is passing. So this is how to calculate self-inductance whenever they are giving question on this. And energy stored in inductor, energy density, self-inductance of solenoid. So on this also they may ask number of turns 2 times. What happens to length? When length of, means what happens to self-inductance when length of the solenoid is constant? When number of turns per unit length is double. So number of turns per unit length is different, number of turns is different. You have to see very carefully. So that is directly proportional to N square, self-inductance. So if you remember all these formulas, you can do any problem on self-inductance easily. Thank you.